My name is Tim Hall. I work for, I'm an independent consultant currently working for a university in the UK. I've been working with Oracle products for somewhere between 18 and 19 years. In that time, I worked with the database, started as an Oracle Forms programmer, became a PLSQL programmer, and then became a DBA. And now, I guess like many people in the room, you do whatever you're told to do by your boss. So I'm similar. For the last about 7 years, I've been part of the Oracle ACE program, which is a community program by Oracle where they just say thank you for being involved in the Oracle community. The reason I got invited is because of my website, oraclebase.com. So about 13 years ago, I started to write information on the internet, articles, and this is my website. So if you've ever searched for anything on Oracle, certainly if you're searching in English, you may have come across it. So as part of my role as being a DBA and a PLSQL developer, I'm often asked to help with performance issues, especially with PLSQL, which incorporates quite a lot of the Oracle stack. So the subject of this talk is about the most common things I see, the most common mistakes I see in PLSQL performance. So can you just put your hand up if you program PLSQL? Okay. Quite a lot. I was worried I might be talking to business people rather than programmers. How many people are DBAs in the room? Oh, okay, that's good. Okay, so hopefully this will all be relevant then. So I've written a couple of books, but they're very old, and you can get all of the information for free off my website. So don't buy them. Okay. So let's jump straight in then to the talk. What is the number one problem I see performance-wise as far as PLSQL is concerned? Well, the number one performance problem is people use PLSQL. So if you want to improve the performance of your PLSQL, stop using PLSQL where it's not appropriate. Okay? So remember that PLSQL is a procedural extension to SQL. It's not a replacement for SQL. So you should always try to solve your problems in SQL first, and only if you can't solve them in SQL should you start writing procedural code. Okay? So why? Because it's quicker that way. So my opinion is, when you're trying to become a great PLSQL programmer, you should focus on becoming an SQL expert that knows a little bit of PLSQL. You shouldn't focus on the minute detail of PLSQL until your SQL is really, really good. Obviously, the ideal is to be brilliant at both. So just remember, there's lots of cool stuff out there in SQL, things like analytic functions that allow you to do things that previously you might have had to be using a procedural language for, like PLSQL, Java, .NET. So learn all the cool stuff in SQL. Now I've just got to run a setup script so that I can, whoops. I had a bit of a scare this morning. My virtual machine I'm running the demos on died, and I had to recover it from a backup. So I was in my room upstairs panicking, thinking, oh God, I've got to stand in front of on stage in front of all these people, and I have got nothing to show them. But luckily, the recovery worked. The first problem I see, unnecessary use of PLSQL. So I'm going to talk about 4 things now, where really common mistakes, where people use PLSQL when they should use SQL directly. The first one is the use of UTL file in order to read data into the database. When I started working with Oracle 7, I did this all the time. because it was the only way I knew how to do. Then someone taught me about SQL Loader, which was a much better solution because it's quicker. And then in Oracle 9i, Oracle gave us external tables, which are an even better solution. So let's have a look at an example of using external table and compare it to PLSQL. So I'm going to make sure, can you see that okay? I can't make the resolution much bigger, so if you can't, just squint. Okay. So I'm going to make sure, create a directory object. Make sure my user can create directory objects. The next thing I'm going to do is spool out 10,000 rows of data. Ah, that's better. Now I'm going to fall off the back. So I'm going to spool out 10,000 rows of data into a flat file. It's going to be comma separated. This is going to be my source data that I'm going to use for my test. So there go 10,000 rows. I've spooled those into the /tmp directory on my virtual machine. I'm then going to create an external table. So the table's called objectxt. The structure of the table matches my comma-separated file. I've told it the directory object. I've said the name of the file. And I've said that every new record represents a new row, and the fields are terminated by commas. I've set parallel to 1, so it's not going to work in parallel. And I've said just carry on going even if you get errors. So that's my definition of my external table, which will allow me to read my file from the file system. I'm now going to create a table to read the data into. That matches the same structure. I've made this example very simple. So now what I can do to read that information from the flat file into this is run a single statement. Insert append into the real table from the external table. And we can see that takes about half a second. If I query the destination table, I can see all 10,000 rows got inserted. So that's good. Very simple. Transferred all the data from the flat file into the database with one SQL statement. How would I do that in PLSQL? Well, there are several ways, but if I used UTL file, I might do something like this. Create a collection that matches my table structure, open the file, loop through it, getting the next line of the file, split that into its columns, put the columns into the collection. When I've run out of data, I get the no data found, and I close the file. And then I can upload it to the database using a bulk operation. So that seems reasonably efficient. Except what we see now is that took about 2 seconds. So that took 4 times as long as doing it with an external table. So what we can see is by taking PLSQL to solve this problem, rather than using SQL directly, we've actually reduced our performance. That's just wasted CPU, which costs a lot of money because licenses for Oracle aren't cheap. Okay. So that's problem number 1 that I see regularly. Problem number 2 is people writing merges using PLSQL when they could use SQL directly. So remember, I've just loaded 10,000 rows into my table. Okay? So now, what I'm going to do is spool out 20,000 rows into that flat file. Can you put the lights down a little bit? No one wants to look at me anyway, so that's okay. Okay. So you can imagine that I'm really beautiful and thin now. Okay? I can't even hide behind this because you can see through it. So I'm going to now spool out 20,000 rows. I've already got 10,000 rows loaded into my database, into my table. So approximately half of these rows will be new, and half will already be there. What I can do now using the external table, I'll spool the data out, 20,000 rows. Now what I can do is use merge into my destination table, using my external table, match on the object ID. If there is a match, I know I've got to update an existing row. If there isn't, I know I've got to do an insert. One statement in SQL, and you'll see there if it wasn't off the side of the screen. Let's see if I can do something about that. Yeah. Okay, 20,000 rows merged in less than half a second. What's my alternative to doing this the simple way? Well, I can write some code to do that. So one option I have is to define a collection, fill that up with my data from my external table, and loop through that data, doing an update. If no rows are touched by the update, I know the data wasn't there, so I need to do an insert. So I do an insert. But what we can see from that is that takes nearly 2 seconds. So that's 4 times slower than just doing the insert. So the PLSQL solution is a waste of time compared to the straight SQL solution, the merge. But I can make it even worse. In this case, I chose to update and conditionally insert. What happens if I had chosen to do it the other way around and do an insert and, do an insert, and on duplicate value on index, that means the row already existed, do an update. Well, in that case, it takes nearly 4 seconds to complete. So this is 8 times slower than the merge. So not only was the PLSQL solution slower, but if I pick the wrong solution, it's even slower. Okay, so once again, that's just throwing away CPU, and CPU costs a lot of money because the Oracle licenses per core are very expensive. Okay, so that's point 2. The third thing I see regularly when I look at people's code is they code multi-table inserts manually. What Oracle allows us to do is have a query, and for each row returned from that query, insert into several tables. So what I'm going to do is create 3 new tables, tab 1, tab 2, and tab 3, based on my external table. So the first one is the same structure as my external table, but with no data. The second one is the first 2 columns, but with no data. And the third one is the first 3 columns, once again, with no data. So these are my 3 destination tables. And what I'm going to do is write a query that populates these all at the same time. So my first option is insert all. And what that means is for every row returned by this query in this case from my external table, I'm going to insert into all 3 of these tables. Okay? So notice that external table had 20,000 rows in it. This statement has inserted 60,000 rows. 20,000 times 3 is 60,000. I'm not so good at maths, but I know that. The next option I have is to do this conditionally. So once again, insert all means that all 3 of these conditions will be tested for every row coming out of this. So for every row, I will say, does the owner column equal sys? Yes. Okay, I insert. If not, I don't. Does the owner column equal system? If it does, I insert. If it doesn't, I don't. And then 1 equals 1 is always true. So for every row coming out of this, I will always insert into that table. So notice now, 20,000 rows coming in and sort of a little over 30,000 rows inserted. And my final option for a multi-table insert is insert first. So this is like a case statement. For every row that comes out of this, Oracle effectively runs this like a case statement, and the first condition that's true is the only operation that happens for that source row. So if my object ID column has a value less than 1,000, it will go into tab 1, and that's the only table that will be inserted. If the owner is system, it will go into table 2, and that's the only table that will be inserted for this row. If none of those are true, then table 3 will get inserted. So 20,000 rows coming from the source table, 20,000 rows inserted in total into a combination of my destination tables. So Oracle makes that very easy to do a multi-table insert. Without that functionality, I would have to loop through the data doing conditional inserts using PLSQL, which would be much slower. And the last one in this particular thing about using unnecessary PLSQL is when you start using bulk operations to solve problems that are no longer problems. You would often have situations where you would like to perform a single DML, say a big update, but there was a danger that that DML could raise an exception. So if I update 1 million rows, I do all of that work, but on the millionth row, that row raises an exception, Oracle throws away all the work I've done already. And that's a problem. So what would often happen is to make sure our code went past exceptions, we would alter our single DML statement to be a bulk operation using the save exceptions clause, which would allow it to go past the exception and allow our operation to complete. And that was a good solution prior to Oracle 10G Release 2. But in 10G Release 2, we got DML error logging, which means that DML can now go past exceptions and complete normally. So let's have a look at an example of that. So I'm going to create a test table called source. It's got 3 columns. Notice the code column is optional. I'm going to populate some data, just some dummy data, but notice that row 1,000 and 10,000 has the code column set to null. So when I insert this, all but 2 rows have got a value in code, but 2 rows have the value null. If I now create my destination table, I'll create that matching the source table, except the code column is now mandatory. So if I pull the data from the source table to the destination table, it's going to fail because I'll be attempting to insert null into this column for 2 of my rows. This is another test table we'll talk about later. So at the moment, if I did my insert select, it would fail. So what I'm going to do is create an error logging table using the dbms errlog package, create error log, passing in my table name. What this is going to do is create a table for me that allows me to trap errors, but also gives me the source data that caused the error. So notice my 3 columns from my base table are there, but they're very big and generic, so that if the data is incorrect for the real data type, I can still see it in the error log. So now what I can do, if we look at this bit here, insert into destination table, select star from source, and it fails. Why? Because I attempted to insert null into the code column. But if I now do the same statement, but include the error log clause, so insert into dest, select star from source, log errors into $dest, and then I put a tag in here that indicates what this operation is. If this were a batch process, I might put the name of the process plus today's date, so that I could look back historically at failures. But what we can see is now that DML statement ran to completion, but it didn't do all 100,000 rows. It's missing 2. If I query that log table using the tag insert, I can see why those 2 rows failed. Because, not surprisingly, I attempted to insert null into the code column. So it's very easy to now make a single DML statement complete past exceptions, so I don't need to use PLSQL anymore for that sort of operation. To show you another example, I'm going to insert some child data into a dependency of the destination table, a master detail relationship. If I now try and delete from the destination table, it fails with an integrity constraint violation, as we would expect. But if I do the delete with the log errors clause, it's now going to complete. And it deletes all but those 2 records that would have caused orphans. If I query the log table, it tells me why those 2 didn't delete, because I attempted to do a delete which caused an integrity constraint violation. So once again, I'm able to now use DML to solve this problem rather than PLSQL. And we know that DML is normally faster than PLSQL solutions to do the same operation. And not only are they faster anyway, but because they're DML, they're very easy to make run in parallel. Normally, we just turn on parallel DML and have a few hints around to make it work in parallel. Making PLSQL run in parallel is significantly more difficult. So not only are these faster, but if your server can cope with the extra load, they're really easy to make even faster. So I've now talked about why you shouldn't use PLSQL, which, you know, for someone like me that's a fan of PLSQL probably sounds kind of strange. But remember, PLSQL is only to be used if you can't do the job with SQL. So now let's talk a little about PLSQL proper. PLSQL is 2 languages. There is the SQL part, which is run by the server, and then there's the procedural part, which is run by the PLSQL engine. So whenever we have a piece of PLSQL, Oracle is using 2 different engines to run that, and the switch from procedural to SQL and back from SQL to procedural takes time and CPU. It's called a context switch. So from Oracle 8i onwards, Oracle gave us the ability to use bulk binds to reduce those context switches. So after telling you you shouldn't use bulk binds and you should use DML error logging, I'm now saying if you do need to use PLSQL to solve a solution, and that solution requires touching many rows, you should definitely use bulk binds. What does this mean? Rather than me getting individual rows from the database, what I can do is define a collection and use bulk collect into my collection. So I'm saying to Oracle, here is my select statement, here is a collection, bring me back all of that data, put it into the collection, and send that back to me, rather than giving me 1 row at a time. And that's much more efficient. Let's have a look at a code example of this, just to show you a performance difference. Whoa, that's a bit big. Small, sorry. Okay, so hopefully you can see that. So what I've got then is I'm defining a collection. I'm then going to do a cursor for loop and manually extend and populate the collection. And I'm timing this using DBMS utility getTime. So I'm getting the current time, doing the test, getting the time again, and the difference between those times is the elapsed time in hundredths of a second. I'm then going to repeat a similar test, but this time use bulk collect into. And we'll look at the performance of these 2 operations, one using a bulk bind and one not. So what we can see here is when I do the regular cursor for loop and build the collection, it takes, well, normally we can expect an order of magnitude difference. That's not quite the case here, but it's not unusual to see an order of magnitude improvement in performance simply because we've got rid of the context switches. So we can see that the bulk operation is quicker. Now, what we have to remember is collections are actually arrays in memory. So this can be quite dangerous because if we're dealing with a very big table, we're going to pull all of those rows back into our session memory. The DBA isn't going to be very happy. So possibly a better solution is to pull chunks or arrays of data back. So what we can do is open a cursor, probably the only time I will recommend using an explicit cursor. Fetch the data using bulk collect and the limit clause. So I'm using the limit clause to set my array size, in this case setting it to 1,000. And what this will do is allow me to go through chunks of data down the table until I get to the bottom, and then process each individual chunk however I want to do that. So let's have a look at an example of that, just to make sure it actually does work. And what I can see is I'm going down the table in 10,000 row chunks in this example. When I get to the last call, I get the remaining rows, and then I come through, do another call, the 0 rows, and I stop. So this allows me to get the efficiency of a bulk collect whilst not flooding my memory, so I can have chunks of data processed in a loop. Now, in Oracle 10G, Oracle introduced an optimizing PLSQL compiler. What that does is takes your code, and at compile time, it rewrites bits of it. So if it sees something that's not very efficient, it will rewrite it and make it more efficient. One of the impacts of this is if you ever do this, a cursor for loop, in 9i, this is going to be slow because it's a row-by-row operation. In 10G, this actually gets rewritten to this for you, but that limit is set to 100, and we can't change that. So as a result, from moving from 9i to 10G or above, you start using bulk binds even if you don't know it. And we can prove this quite simply, well, if my demo works. So what I've got is an explicit cursor. I'm going to use that for most of the tests. I'm going to time, though, just doing a cursor for loop, a regular cursor for loop, but doing nothing in the loop. This is just the time it takes to process that data. I'm going to compare that to the time it takes to do a bulk operation with a limit of 10. And I'm suggesting in 9i this would have been quicker because I had 10 times less context switches. But in 10G or above, this is going to be slower because effectively I've reduced the array size compared to the default. I'm going to repeat the test with an array size of 100 and then again with an array size of 1,000. And let's look at the difference in performance. Ooh. So what we can see from this is when I do the regular cursor for loop, it actually works faster than the bulk operation. But it's comparable to the bulk operation with an array size of 100. Why? Because this is actually getting rewritten into that format. But then if I do a bigger array size, I can reduce the context switches further and maybe get some slightly better performance. The improvements you get by changing array size depend on the work you're doing. If I have very, very big rows, lots of columns, lots of wide columns, like large varchar 2s, then having a big array size could be dangerous because I'd be pulling back so much data, it would use a lot of memory. If I've got very small rows, maybe just an ID, I can pull back lots and lots, maybe 50,000, 100,000 rows without wasting too much memory. So although Oracle will actually do some performance improvements for you by rewriting this to this, I would suggest that you should always do this sort of operation, getting data from the database to your code manually like this so you can control that array size and get the best performance. But if you're just left with lots of legacy code that runs like this, at least the move to 10G or above will have improved it. So that's getting data out of the database into my procedural code. How do I get it back? The way I get it back into the database is to use the FORALL construct. So it looks similar to a for loop. Any idea? I can just do a little bit of a dance. Ah, right, okay. So that could have been really embarrassing. So it looks similar to a for loop, except I use the keyword FORALL. There is no loop keyword, and there is no end loop. So what I'm saying here is, here's a collection, have the DML statement, go away and do the work, and just give me the result back, rather than going, do an insert, thank you, do an insert, thank you, one at a time. So let's look at the code for that. I have a collection. I'm going to fill it with, what's that, 10,000 rows of data, just dummy data for my example. I'm then going to time how long it takes to do a regular for loop through that data, doing individual inserts, and compare that to the amount of time it takes to do an insert using the bulk bind operation, FORALL. And what we can see is similar to pulling the data back. Typically, we can expect an order of magnitude improvement in performance when we're doing a DML operation using FORALL. Why? Because we're passing all of the data in a collection. We're not doing a row at a time. So we've reduced the context switches. And remember, context switches are memory, and are CPU, and CPU costs money because of licensing. So anything you can do to reduce CPU load is a good thing for your pocket. There are a few gotchas where bulk operations are concerned. The first thing is triggers. When you do a normal insert in a for loop, for every insert, you get a before statement, a before row, an after row, and an after statement timing point. When you do a bulk operation, you only get a before statement at the very top of the collection and an after statement at the very bottom of the collection. So if you switch from row-by-row processing to bulk operations and you've got triggers on your before and after statement timing points, you may get an unexpected result. So think of this almost like a straight insert select in terms of the way the triggers fire. That's only for the bulk insert, though. The bulk update and delete work in the same fashion you would expect. Bulk operations expect to use dense collections. They don't expect to have gaps in the collection. If you fill the collection, then delete elements, what you'll find is they will fail. The way you get around that is to use the indices of and the values of clauses. These allow you to use sparse collections. If you use SQL%row count after a bulk operation, you get the count of every row that that bulk operation touched. If you want to know what each element of the collection touched in terms of the numbers of rows it touched, you have to use SQL%bulk row count, and that will give you a value for every individual element of the source collection, how many rows it touched. If you want to make sure that a bulk operation using FORALL completes, even if it raises exceptions, you add the save exceptions clause, and you can look at exceptions that were fired using the SQL%bulk exceptions pseudo collection. So bulk binds are probably, after making sure you're using SQL properly, bulk binds are probably the second most important thing to make your PLSQL run fast. So this is probably the briefest explanation of bulk binds you'll ever have had, but I'll point you to some articles I've got on this that will give you more detail. Okay, so moving on. The next thing, a very quick win, is to use NOCOPY hint. When I started programming PLSQL, nearly every out and in-out parameter I used was very small. Dates, numbers, small varchar2 variables. So I didn't care how Oracle processed them because they were quick. The problem is, we're now starting to pass very big and very complicated variables like lobs, XML types, or even collections as parameters. And then the efficiency of the way Oracle passes parameters becomes very important. So by default, Oracle does a thing called pass by value. What that means is I have my formal parameter that I pass in for an in-out variable. I will then, inside the procedural function, create a temporary buffer of the same size, copy all that information into it. Inside the procedural function, I work with the temporary buffer, and on successful completion of the procedural function, that data is copied back into the formal parameter for me to see outside as an out or in-out parameter. The time it takes to create that temporary buffer, copy the data, and copy it back is wasted time. The memory used for the temporary buffer is wasted memory. So when you're dealing with large or complicated objects, you should use the NOCOPY hint for out and in-out parameters. This has the result of changing the pass by value default behavior to pass by reference. What that means is, rather than creating the temporary buffer and working in that, we work directly in the formal parameter. It's like a pointer if you've ever programmed C. It's like using a pointer rather than copying the value. So this makes life a lot more efficient. How do we use it? If we've got an out or in-out parameter, we just add NOCOPY, and that will change from pass by value to pass by reference. I've got an example of this, and it's quite, there's a lot of code, but it's very simple, so I will try and get through it, just point out obvious bits. I'm going to test the amount of time and the amount of memory used by a single call to with an in-out parameter and a single call with an in-out NOCOPY. I have a collection. Right at the bottom of this code, I'm going to populate that collection with 1,000,000 rows of that. So it's going to be quite a big collection. In each of my tests, I'm just going to get the time, call that procedure once with a normal in-out parameter, check the time again. Then do the same, but this time, check the amount of memory in my session. Repeat those tests, calling another version of the procedure that uses a NOCOPY hint, and compare them. And notice I'm going to reconnect every time between each test so that I get a nice clean session each time. So you can look at this code when you've got some spare time if you're interested. So what I can see then is when I called the in-out parameter once, the in-out procedure once, passing this large collection, it took about 3/4 of a second, okay, nearly a second. When I called the same procedure, but using the NOCOPY hint, it was instantaneous. Why? Because I didn't have to create and populate the temporary buffer and then copy the data back. So all of that is wasted time and wasted CPU. As far as memory is concerned, when I used the regular in-out parameter, because this was a large collection, Oracle had to give me more memory for my session to hold that collection in memory. When I used the formal parameter, when I used the NOCOPY hint, I was working directly in the formal parameter, not having to build a temporary buffer. I didn't allocate any extra memory at all. So wasted time, wasted memory by using pass by value. So if you're using large or complicated parameters for out and in-out parameters, use the NOCOPY hint. Just a word of warning. There are some slight differences in the way that error handling is processed, because with the temporary buffer, the data is only copied back to the formal parameter if no exceptions fire. Whereas with this method, you're automatically writing data directly back to the formal parameter. So just be a little bit careful about testing out parameters to see if successful completion has happened. You should always, if there's a failure, propagate an exception or have a status flag separate. Okay, so that's NOCOPY hint. Now some very quick points to bring, data types. I will have to race through this a bit because I'm running out of time. Oracle provides us with lots of data types. the thing we've got to remember is if you don't use the right data type, you'll get worse performance. But also, if you're comparing or assigning values between different data types, Oracle has to do an implicit conversion. That takes time. So using the wrong data types slows down your code. And I have an example of numeric types are probably the easiest thing to discuss this with. So I've got an example comparing the performance of numeric types. So I have lots of variables of different types, and I'm just going to time loops of doing very simple mathematical operations, like, in this case, addition, using number variables, integer, PLS integer, binary integer, and simple integer. Then I'm going to do the same sort of test comparing number with binary float and binary double, just to see what the different performance of these data types are like. So for the first test, what I can see is number is the default thing everyone uses. It's an internal type. The Oracle program itself does all the maths, okay? And what we can see is that's how fast this operation runs. If I use integer, it's even slower. Why? Because integer is also an internal type, but it's constrained. Oracle has to do extra checks on it to make sure it hasn't gone outside of the integer boundary. So if you use integer types in your PLSQL, you're adding a performance problem straight away. If you use PLS integer, binary integer, or simple integer, they're all a lot faster than number. Why? Because they're machine arithmetic. Oracle offloads the maths to the underlying architecture and says, you do the maths for me and send me the result back. That's a lot quicker than Oracle doing the maths itself. So if you're using integers in your code, use one of these three data types. These two are effectively the same type. In Oracle 9i, this was very slow. But then in 10G and above, it became the same speed as PLS integer. Simple integer is similar performance in interpreted code, but in native code, it's nearly twice as fast because it doesn't allow assignment of null, and it doesn't have boundary checks. It just wraps around. If we're looking at real numbers, we can see that, once again, number performs as you'd expect. But binary float and binary double are nearly twice as fast, typically. Why? Because they're machine arithmetic. Oracle offloads the work to the underlying architecture. The thing you have to be careful with these is that each architecture uses slightly different floating point arithmetic, so you might get slightly different rounding, but assuming you're working on the same architecture throughout your organization, that's not a problem. So pick the right data type for the job you're doing to improve your performance, and try and minimize implicit conversions between data types. Some very quick points to finish off. First off, stop using index searches, use row ID. If you know you're pulling data back from the database to instantly update it, do a select for update, including the row ID, and then when you do the update where row ID equals the row ID you returned. Provided you do the select for update first, it's safe, because nothing else can touch that row. If you don't do the select for update, or if you hold the row ID for a long time, an update to the table may cause the row ID to change. If maybe the row has moved into a different partition, or if a DBA has done a shrink operation, the row ID can change. So you must lock the row. Use Oracle built-in functionality wherever possible. You very often find that in every new release, new code gets released in the DBMS packages that do things that you've always wished Oracle included, but you still carry on using your old routine for doing that. You will often find that the Oracle built-in routines run a lot quicker because most of them are actually part of the kernel. They're running as machine code. They're not written in PLSQL. So by definition, they're going to be faster. So try and use the built-in functionality rather than your homegrown solution. Stop using explicit cursors. Unless you're using a bulk operation, you need to do select into or cursor for loops, as they're more efficient than using a cursor definition with open, fetch, close. Why? Because by default, PLSQL is interpreted. The more lines of code you have, the slower it's going to be. Cursor for loops and select into use less code. They're a lot quicker. So unless you're using a bulk collect, using the limit clause, you really shouldn't use an explicit cursor. If you stop avoiding instrumentation in your code, Tom Kite would probably tell you that every other line in your code should be a trace message so that you can tell what your code is doing all the time. You turn on your trace, you see exactly what's happening. In my opinion, if you have to look at your code to understand why something happened, you've failed. Okay? Put as much tracing in your code as possible. The next two are fairly similar. Short circuit evaluation. Most languages, if the left-hand side of a Boolean expression allows you to predict the right-hand side is no longer evaluated. So, for example, we know that true or false is true, and true or true is true. Therefore, if the left-hand side of an OR expression is true, Oracle doesn't evaluate the right-hand side. Okay? By the same token, with AND expressions, false and true is false. False and false is false. So if the left-hand side of an AND expression is false, Oracle doesn't evaluate the right-hand side. So always put your least expensive tests to the left-hand side of your Boolean expressions, and sometimes you'll get a nice quick win. If you're calling a function that returns a Boolean, that function might never get run if it's on the right-hand side, which has got to be a bonus, because the quickest way of improving performance is to stop doing some of the work. In a similar manner, logic order, else if lists and case statements start at the top and work down. So they test every comparison until they find something that's true. So you should put the most likely outcomes at the top of the list. What people tend to do is deal with all their exception cases and then at the bottom say, else do the normal processing. If the normal processing happens 99% of the time, you're doing all of these comparisons for no reason to get to the bottom of the list. So put the most likely outcome at the top, and your else if and case statements will be faster. And the final point, stop waiting for requests to complete if you can decouple processes. When you do internet banking, you transfer some money. Do you wait 3 days for the screen to come back to tell you the transfer is complete? No, of course you don't. It comes back and says, yes, we've got your request, we're going to do that. And sometime in the next 3 days, the money transfer happens. Your code should do similar things. If you've got a client application that's got some very intensive processing, when you press certain buttons, queue that processing and do it later. So the user experience is very fast, but you can batch all of that work up and do it more efficiently in a batch process. So quick race through the worst things I see that affect performance in PLSQL. Now, I have an article that goes with this. You can download the slides, the example code, and read the article. So if you go to my website, there is a page, a very plain page, called, you probably can't see that, that's oraclebase.com/workshops. And in there, PLSQL, stop making the same performance mistakes. You can get the slides, the demo code, and there's an article link. That article takes you to this, which is everything I've just said written down in an article. And it's got links to lots of individual articles that have got more detail on each of these points. And you also have a translate button, which probably translates to the worst Portuguese you've ever seen in your life. I'm not on the internet at the moment, so I can't use it. But allegedly, it will give you Google's version of perfect Portuguese. It'll probably be more like Greek. So that's me, Tim Hall, from the UK, a little place called Birmingham in the centre, not from London. The only place that anyone knows in the UK, apart from Manchester, because Manchester United. So If anyone's got any questions, come and speak to me. I love talking about Oracle, so I'm happy to speak to you. Thank you very much.